Hello students, I am Swarnalata Sharma teaching at Kendriya Vidyalaya Muradabad. Today we will study about a new chapter, Principle of Mathematical Induction. In this chapter we shall go through the introduction, motivation, principle of mathematical induction and applications, in which we shall solve some problems involving sum of the series, divisibility and inequality. One key basis for mathematical thinking is deductive reasoning. An example from the study of logic is an argument expressed in 3 statements. Socrates is a man, all men are mortal, therefore, Socrates is mortal. If statements A and B are true, then the truth of statement C is established. To make this simple, let us take a mathematical example. 8 is divisible by 2. Any number divisible by 2 is an even number. Therefore, 8 is an even number. If statement first and second are true, then the truth of statement 3 is established. Thus, deduction in a nutshell is given a statement to be proven, often called a conjecture or a theorem in mathematics. Valid deductive steps are derived and proof may or may not be established. That is, deduction is the application of a general case to a particular case. In contrast to deduction, inductive reasoning depends upon working with each case and developing a conjecture by observing incidences till we have derived each and every case. It is frequently used in mathematics and it is a key aspect of scientific reasoning where collecting and analyzing data is the norm. Thus, in simple language, we can say that the word induction means the generalization from particular case or facts. Now, first let us understand what we mean by the terms like statement and mathematical statement. Thus, in simple language, we can say that the word induction means the generalization from particular cases or facts. Now, first let us understand what we mean by the terms like statement and mathematical statement. Statement. What do you mean by a statement? It may be a sentence or description which can be judged to be true or false. For example, we have 2 divides 6. Jaipur is the capital of Rajasthan. There are 5 days in a week. X plus 1 is a factor of x square minus 3x plus 2. A union B is equal to B union A. Look students, here statements 1, 2 and 5 are true statements, whereas statements 3 and 4 are false. Can you observe? See, what are mathematical statements? Statements involving mathematical expressions are known as mathematical statements. Let us see some examples to understand them perfectly. Let us take first example as, let Pn be the statement 10n plus 3 is prime. Now, what is P2? Obviously, 10 into 2 plus 3, that gives us 23 is prime. That is, P2 is true. What about P3? It will become 10 into 3 plus 3, that gives us 33 is prime. That is, 33 is prime, clearly P3 is not true. Let us look at one more example. If Pn is the statement, n cube plus n is divisible by 3. Let us check whether the statement P3 is true. P3 is the statement 3 cube plus 3, which on calculation gives us 27 plus 3 is equal to 30, is divisible by 3. Clearly, it is a true statement. Now, let us check for P4. It is the statement 4 cube plus 4 is equal to 68, is divisible by 3. Obviously, it is not true. Let us look into one more interesting example. Let Pn be the statement 7 divides 2 power 3n minus 1. What is Pn plus 1? Pn plus 1 is the statement 7 divides 2 power 3 into n plus 1 minus 1. Here, Pn plus 1 is obtained by replacing n by n plus 1 in P of n. Let us see one more example. If P of n is the statement n square greater than 100, prove that whenever Pr is true, P of r plus 1 is also true. The statement P of n is n square greater than 100. Let Pr be true. Then r square is greater than 100. We wish to prove the statement P of r plus 1 is true. Look how we can do it. R plus 1 whole square is greater than 100. Now, P of r is true implies r square is greater than 100. That can be rewritten as r square plus 2r plus 1 greater than 100 plus 2r plus 1. What we have done here? We have added 2r plus 1 on both the sides. R plus 1 whole square is greater than 100 plus 2r plus 1. That implies r plus 1 whole square is greater than 100. Obviously, Pr plus 1 is true. Since 100 plus 2r plus 1 is greater than 100 for every natural number r. Now, students, look into this interesting example. If P of n is the statement n into n plus 1, n plus 2 is divisible by 12, prove that the statements P3 and P4 are true, but the statement P5 is not true. Let us see how. P of 3 is the statement 3 into 3 plus 1, 3 plus 2, that gives us 60, is obviously divisible by 12. It is a true statement. P4 is the statement 4 into 4 plus 1, 4 plus 2, that is 120, is divisible by 12. It is also true. Now, let us see what happens with P5. P5 is the statement 5 into 5 plus 1, 5 plus 2, that gives us 210 on calculation. It is divisible by 12. Clearly, it is not true. One more example here. Let Pn be the statement n square plus n is an odd integer. Show that if P of m is true, then P of m plus 1 is also true. Look here, the given statement P of n is n square plus n is an odd integer. Let Pm be true, that implies m square plus m is an odd integer. Now, m plus 1 whole square plus m plus 1 can be simplified as m square plus 2m plus 1 plus m plus 1. Look, on simplification we can write it as m square plus m plus 2m plus 2. What do you observe in these two terms? First expression is an odd integer with the help of first equation plus 2 into m plus 1. This gives us an even integer. That means, we have got an odd integer and even integer, since 2 divides 2 into m plus 1 for every m belonging to n, which on addition gives us an odd integer. This implies P of m plus 1 is true. Now, Do you remember what is an odd integer and what is an even integer? An even integer is always divisible by 2 and an odd integer is not divisible by 2. For example, 1, 3, 5, 7 are odd integers and 2, 4, 6 and 8 are examples of even integer. So, students, today we have learnt about inductive approach, deductive approach, statement, mathematical statement, and we have also learned that one key basis for mathematical thinking is deductive reasoning. In contrast to deduction, inductive reasoning depends on working with different cases and developing a conjecture by observing incidences till we have observed each and every case. Thus, in simple language, we can say that the word induction means the generalization from particular cases or facts. The principle of mathematical induction is one such beautiful tool which can be used to prove a wide variety of mathematical statements. Each such statement is assumed as P of n associated with positive integer n, for which the correctness for the case n is equal to 1 is examined. Then, assuming the truth of P of k for some positive integer k, the truth of P of k plus 1 is established. Today, we have learnt about inductive approach, deductive approach, mathematical statements. In the next session, we shall discuss about the principle of mathematical induction and how it can be used to solve various types of problems. Thank you. Have a nice day.